Hi everyone. So welcome back in this sampling distribution lecture series. So as you know, we have completed the chi-square distribution, but the application part is still not covered, right? वो हम देखेंगे once we complete the T and F distribution. After that, we will start the application of chi-square. Application of Z test, application of chi-square test, application of T test and F test. वो हम बाद में देखेंगे. Clear? First we will see the distribution we did chi-square distribution, and now we are going to start the T distribution. Then after T we will have the F distribution. So what's T distribution? What is T distribution? Or you can say students T distribution. Students T distribution. In this, what we will learn in T distribution, same like in chi-square distribution, we did constants of chi-square, mode of chi-square, expectation of chi-square, MGF of chi-square, and some theorems plus some examples. Same will be in T distribution and F distribution, right? So this T distribution is also a parametric distribution. Parametric distribution. This T distribution is also a parametric distribution, and this T distribution is again that's like chi-square distribution. It's a continuous distribution. It's a continuous distribution. In general, we do not have the discrete distribution for sampling distribution. We generally study sampling distribution for continuous distributions. Clear? So say, what is this T distribution? Let xi, I is equal to 1 to up to n be a random sample. Whenever we talk about sampling distribution, we talk about random sample. Let xi, that's I is equal to 1 to up to n, be a random sample of size n from normal population with mean mu and variance sigma square. So say this normal population makes the T distribution as parametric distribution. Whenever we have the normal population for any distribution, then the distribution will be called a parametric distribution, right? So this T distribution was given by W. Gossett, and his student is one of the students. That's the name of his students is not known. That's why this distribution is called T distribution or students T distribution, as his student worked with him in this distribution, and he wrote this distribution under his name, that student T distribution. Clear? So it's something like this. T is equal to, or let's write it in capital letters, T is equal to x bar minus mu divided by s upon under root n. This will follow T with n degrees of freedom. Say, whenever sigma square is not known, sigma square is not known, we replace sigma square by s square, and the distribution becomes T distribution. If x bar minus mu upon sigma upon under root n. This will simply follow normal 0 comma 1. But if this is unknown, the distribution will be called as T-distribution. Whenever sigma or sigma square is unknown, we replace the sigma square by s and the distribution will be called as T-distribution. Here the s or s square will be 1 upon n minus 1 summation xi minus x bar whole square, where I is equal to 1 to n. And this s square will be unbiased estimator of sigma square. In sampling आपने ये प्रूव किया होगा कि एक्सपेक्टेशन ऑफ एस स्क्वायर विल बी इक्वल टू सिग्मा स्क्वायर, ये आपने प्रूव किया होगा, ठीक है. समटाइम्स आप देखोगे कि समटाइम्स t follows tn minus 1. This n minus 1 is also degrees of freedom, and this t follows tn, n is also degrees of freedom. कंफ्यूज नहीं होना कि t and t n minus 1 यहाँ पे है क्या. So what's degrees of freedom? That's number of observations minus independent constants. That's the restrictions, simply. Now, what is the PDF of this T distribution? Let's see. PDF of T distribution is f of t is equal to 1 upon under root n beta 1 by 2 n by 2 beta 1 by 2 n by 2 1 plus t square upon n n plus 1 by 2, and the range of this t distribution is from minus infinity to infinity. And in chi-square the range was from 0 to infinity, but in t distribution the range is from minus infinity to infinity. Can we do one thing? Put n is equal to 1 in this equation. Put n is equal to 1 in this equation. What we will get, f of t, we will get something like this: 1 upon beta 1 by 2 1 by 2. This is 1 plus t square upon 1 from minus infinity to infinity. So see how to solve this beta 1 by 2 comma 1 by 2. This will be nothing but simply gamma 1 by 2 gamma 1 by 2 gamma 1 by 2 plus 1 by 2. So this will be equal to, remember the value of gamma 1 by 2 is under root pi. So this will be under root pi divided by 1 plus 1 2 divided by 2, this is 1. So gamma 1 is 1. So this will be equal to only pi square, that is square and root cancel out, we will get only pi. So in place of this we write pi. So f of t becomes 1 by pi 1 upon 1 plus t square, and this is the PDF of Cauchy distribution. Clear? This is the Cauchy, this is the PDF of Cauchy distribution, and this is for n is equal to 1. For n tending to large, when n tends to large, then f of t becomes normal distribution. That's something like this. When n tending to large, t distribution reduces to normal distribution, right? And also In previous lecture, I have told you about that t is equal to x upon under root y by n, which will follow Tn. But what is x here? What's y here? As you can see, n is the degrees of freedom, as you know. But what's x and what's y? So let's comment on these two things. That is, x is nothing but simply this is standard normal variate. That is, the distribution of x is normal 0, 1, and the distribution of y is nothing but chi-square with n degrees of freedom. So see, here in the numerator we have normal, and in the denominator we have the chi-square with n degrees of freedom. So whenever you see this type of equation or this type of term, so simply say that it will follow Tn. It will follow Tn. It will follow Tn. It will follow Tn. So let's see the expectation of this. Say expectation of x will be 0 if n is equal to 1. If n is equal to 1, and this will not exist if n is greater than 1. If n is greater than 1, the expectation will not exist. Or you can write if n is equal to 1. Yeah, if n is equal to 1, if n is equal to 1, the expectation does not exist. If n is greater than 1, expectation of x will be 0. So in general, you remember expectation of t distribution is 0, and variance of t distribution, that's variance of x, that's t distribution, is n minus 2 if n is greater or equal to 2, or does not exist if n is equal to 1. If n is equal to 1, this will not exist. Or if as you remember this t distribution is symmetric about 0. So whenever the distribution is symmetric about some point, then the expectation will be that point. So it's symmetric about 0, expectation will be 0. So this is symmetric, so expectation will be 0. Let's draw the graph of this t distribution. That's something like this. This is symmetric. Here we have the minus Tn alpha by 2, Tn alpha by 2. So this is symmetric. So say here is 50% area, here is 50% area. This is my critical value, this is my critical value. But you don't need to know about this critical value right now. Once we start the applications of t distribution, we will discuss one by one. What's confidence interval, what's confidence coefficient, what's level of significance, what's critical value, what's acceptance region, we will see one by one. Right? So this is valid. This is valid. So if I write like this, for n greater than 2, expectation of x is equal to 0. Variance of x is equal to n minus 2. This variance will exist when n is greater than 2. If n is equal to 2, this will become negative. This will become 0, and the whole term will be not defined. And if n is less than 2, that's let's suppose 1. So variance of some x is always greater than 0. Variation or variability can never be negative. This can never be negative. Variability can never be negative. Or if if r is less than n, and is even, and n is even, then expectation of x r is equal to n r by 2 gamma n plus 1 divided by 2 gamma n minus 2 divided by r whole divided by gamma 1 by 2 gamma n by 2. This is when you have r less than n, and r will be by even. R will be by even. Then the expectation will be like this. So from this we can get the variance also. Right? Right? So remember, odd moments of T distribution is always 0, as T distribution is symmetric about 0. Clear? And this is point number 1. And point number 2, MGF of T distribution does not exist. And number 3, MGF of chi-square distribution also does not exist. इन दोनों का जो MGF है वो exist नहीं करता है, ठीक है? So now let's move ahead. Let's derive the PDF of this T distribution, that is derivation of T distribution. Say if somebody is following the FMS, but I will derive this T distribution by some other methods. I will not follow what FMS, what's in FMS. I will prove this by second method. See, what's that method? Let W is equal to X and Z is equal to T under root W by N, where X will follow chi-square N and Z will follow normal 0, 1. Let's suppose this X will follow chi-square N and Z will follow normal. Now finding the Jacobian. In first place, finding the Jacobian. That is del Z by del T, del Z by del W. Yes. Then del Z by, not del Z, del Z. Yeah. This is del Z by del T, del Z by del X, del W by del T, del W by del X. See, del Z by del T, del Z by del T, from this, that will be equal to, as the differentiation of T is 1, this will be equal to W by N, and del Z by del X, del Z by del, not del X, del Z by del W. this will be equal to, with respect to w, this will be equal to t divided by 2 under root w by n, and del w by del t. So this is incorrect. This is not del w by del t. This is del w by del t. This is correct. Del w by del t. Del w by del t. No involvement of t. So differentiation will be 0. As we treat this x as constant, then differentiation of that will be 0. Del w by del x. Del w by del x. See, here is the involvement of x. So del w by del x will be 1. So the Jacobian will be, this is 1 into this is w by n. As 0 into this is 0, 1 into this is this. So the Jacobian will be under root w by under root n. Clear? Now, as you know, we have f of z comma w, or we can write, we need a new function, that's f of t comma w. We need this t, but we are finding the joint. Why joint? Because we have two PDFs, that's PDF of chi-square and PDF of normal. Simply, so see, what's PDF of normal distribution? That's under root 2 pi e raised power minus t square w by n whole divided by 2, 1 by gamma n by 2, 2n by 2, w n by 2 minus 1 e raised power minus w by 2 under root w by n, as this is the value of Jacobian. This is the value of Jacobian. This is my chi-square and this is my normal. In place of x, this is the value of x. In place of x, as z follows normal 0 comma 1. This is the value of z. Sorry, this is the value of z. Yes, this is the value of z. So see. This will be equal to, let's rearrange the terms. This will be equal to 1 upon gamma n under root pi 1 upon gamma n by 2, 2n by 2 plus 1 by 2 w n plus 1 divided by 2 minus 1 e raised power minus 1 by 2 t square divided by n minus 1 into w, and this is the joint density function of f of t comma w. Now finding the marginal of t, that's the t distribution. We simply do one thing, that's f of t. We need the f of t. We will integrate this from 0 to infinity f of t comma w dw. As if you are following my lectures from the beginning, you know how to find the marginal of some function from the joint density function. So f of t will be 1 upon under root n under root pi 1 upon gamma n by 2, 2n plus 1 divided by 2, 0 to infinity w n plus 1 divided by 2 minus 1 e raised power minus 1 by 2 t square divided by n minus plus 1 into w dw. Now look at this term. This is simply 0 to infinity x n minus 1 e raised power minus ax. So what's the formula for this integral? This is simply gamma n a raised power n. So this will be equal to, once we find this integral, so this will be equal to 1 upon under root n under root pi 1 upon gamma n by 2 2n plus 1 divided by 2, and this will be nothing but gamma n plus 1 divided by 2 divided by a is this 1 by 2 t square upon n plus 1 and multiply and power a raised power n, that's a raised power n, so this is a raised power n is this n plus 1 divided by 2. Now the range will be from minus infinity to infinity. So after solving this gamma, then some terms will be cancelled out. So at the end we will get 1 upon under root n beta 1 by 2 n by 2 1 plus t square upon n plus 1 divided by 2 from minus infinity to infinity. So this is the PDF of T distribution. This is the PDF of T distribution. And then second method that you have in your FMS book, just follow that. If you understand that, well and good. If you don't understand that, then come to this, and this will be easy. Simply this will be easy. Write the joint density function of normal distribution and chi-square distribution and find the value of Jacobian. Then after finding the value of Jacobian, finding the PDF of joint PDF of new variable, that's f of t comma w, then from that you will get the distribution of t. And what are the constants of T distribution? Constants of T distribution. So see, what are the constants of T distribution? Simply, as you know, f of t is symmetrical about 0. As I said earlier that the odd moments will be 0. Will be 0, as mu 2r plus 1 dash will be 0 for r is equal to 0, 1, 2 up to so on. This will be 0, but for even moments, that's mu 2r, that will be nothing but minus infinity to infinity t 2r f of t dt. That will be, as the function is even function, that's t raised power 2r, that's what's even function, that's f of minus t is equal to f of t. This is my even function. If I say f of x is equal to x square, then f of minus x will be also equal to x square. So this is my even function. So as you know the property of integral for even function, that's 0 to infinity 2 times 0 to infinity t 2r f of t dt. Now calculating mu 2r, that is nothing but 2 1 upon beta 1 by 2 n by 2 under root n, that is the PDF of T distribution, that's 2r upon 1 plus t square upon n plus 1 divided by 2 dt. Clear? When this integral will be convergent? That's the convergent is simply, if I say that some sequence will be convergent or some integral will be convergent, that's existence of some integral. Remember, convergent is simply existence of the integral for now. So this will be convergent if 2r is less than n. If 2r is less than n, this integral will be convergent if 2r will be less than n. Then let or put 1 plus t square upon n equal to 1 upon y. So from this, find the value of t square. That is, t square is equal to n 1 minus y upon y. Now the challenging task is to find the differentiate this. Now differentiation of t square will be 2t dt, and here this is u by v. So this is simply u square, differentiation of one function treating the other as a constant. So this will be nothing but treating n as a constant, differentiation of 1 minus y, or simply treating y as a constant, differentiation of this. Treating y as a constant, differentiation of this. So this will be nothing but minus n by y square dy. So here I apply only u by v form of differentiation. So now when t is equal to 0, check this limit. Check this limit. This and this. When t is equal to 0, 1 upon y will be, that's 1. Simply when this term is 0, so this whole term is 0. So reciprocal of this is simply 1. So y is equal to this from 1. And when t is equal to 0, when t is equal to 0, when t is equal to infinity, so 1 plus infinity is infinity. Clear? But reciprocal of infinity will be 0. So limit will be from 1 to 0. Let me rearrange it. Limit will be from 1 to 0. Again. Let me make you understand that, when t is equal to 0, this becomes 1. So 1 by 1 is equal to y, as 1 is equal to 1 by y. So reciprocal of 1 by 1 is 1. Reciprocal of 1 is 1 by 1, and this is y. So y is equal to 1. Simply y is equal to 1. Now see again. When t is equal to infinity, so 1 plus infinity is equal to 1 upon y. So this is infinity is equal to 1 upon y. Now take the reciprocal of this. This is 1 upon infinity is equal to y. So anything divided by infinity is 0. Y is equal to 0. So the limit will be from 0 to 1. Simply limit will be from 0 to 1. Now mu to r is equal to 2 under root n beta 1 by 2 comma n by 2. So this is from 0 to 1. This will become t 2r minus n. This is 1 to 0 t 2r minus n upon 1 by y n plus 1 divided by 2 2t y square dy. Now again, using the property of integrals, whenever we are rearranging the limits, so we will get multiply with minus sign. So mu to r will be 2 minus 2 under root n beta 1 by 2 comma n by 2 0 to 1 t 2r minus n upon 1 by y n plus 1 divided by 2 2t y square dy. So minus becomes plus. So this will be equal to 2 upon under root n beta 1 by 2 n by 2 0 to 1 t square 2r minus 1 upon 2 yn plus 1 divided by 2 minus 2 dy minus 2 dy. So now this will be equal to nr beta 1 by 2 comma n by 2 0 to 1. I'm just rearranging the terms and nothing else. You can refer FMS for this too. R minus 1 by 2 dy, and this will be equal to nr gamma. After solving this, this is simply, what is this? This is simply beta function. This is beta a comma b. What is a? A is this, and what's b? B is this r. This is a minus 1, this is b minus 1. If after rearrange this, here is 1 by 2, you should have here 1, only 1 minus 1. So plus 1 minus 1. So this, rearrange this and this. So this will be nothing but gamma n by 2 minus r. Gamma r plus 1 by 2 divided by gamma 1 by 2 gamma n by 2. So this is your mu to r. If I rearrange this, this is nothing but nr 2r minus 1 2r minus 3 up to 1 divided by n minus 2 n minus 4 n minus 6 up to n minus 2r, where n by 2 should be greater than r and n should be greater than 2. If n is equal to 2, this becomes not defined. N minus 2r. Clear? So in general, mu to r is equal to n by n minus 2. That is not mu to r, that's simply variance. That's mu 2. In place of r, that's 1. So put 1 in this equation. It's 2r. Put 1 in this equation. Put n is equal to 1 in this equation, or 2r, it's r. Put r is equal to 1 in this equation, you will get, it's mu r. You will get n minus 2, where n is greater than 2. And what will be my mu 4? That will be 3n square upon n minus 2 n minus 4. Clear? And what will be my beta 1? That is skewness, that's mu 3 square upon mu 2 cube. Mu 3 is 0, so beta 1 will be 0. As the odd moment, mu 2r plus 1, that is 0. So beta 1 will be 0, and beta 2 will be 3 n minus 2 upon n minus 4. So n should be greater than 4. As n tending to infinity, beta 2 will tend to 3. Beta 2 will tend to 3. How beta 2 will tend to 3? That this is make the n common, 1 minus 2 by n, make n common 1 minus 4 by n. When n tending to infinity, so this becomes 0, this becomes 0. So this and cancel out, so we will left with only 3. So beta 2 will be 3. So these are the some constants of T distribution that we need to remember, and MGF of T distribution does not exist. Clear? So in next lecture we will see some questions as well as some theorems based on T distribution, chi-square distribution, and some examples from the past exams or previous exams.